Welcome to the Gerald R. Ford class ship brief. Ladies and gentlemen, this is the largest and most capable aircraft carrier, not just built in American history, but built in naval history. This is an enormous ship that we're going to talk about today. There's one commissioned right now, the Gerald R. Ford. That's why the class is named after her. We have 3 under construction right now. We're building these 3 at a time because they take so long to build. They will be delivered in 5-year increments. The place building these is located on the east coast of the United States. It's a large shipyard called Newport News of Huntington Ingalls Industries, and that's in Virginia. Each one of these ships displaces just over 100,000 tons of seawater when she's at sea. This ship has a 20% more sortie and weapon capability than the previous class, which used to be the largest aircraft carrier class in the world, the Nimitz class. This one is even larger than that. The defensive systems on this ship may shock you. She is quite capable of defending herself at sea even without the fleet or even the air wing. She has multiple missile systems on board for both point defense and medium-range air defense that we will talk about. Iconically, she is the first aircraft carrier to use electromagnetic launch system called EMALS. This fits well with the large nuclear electrical generation capability of the ship to use electricity instead of steam to push our aircraft off the deck. The aircraft that operate on the Gerald R. Ford class are numerous. We have the FA-18, both E and F, single and dual seat fighter and attack aircraft. We have the F-35C operating off of her, the E-2D Hawkeye, airborne early warning and control aircraft. And of course, the MQ25 is the airborne refueling unmanned aerial vehicle, operates off the Gerald R. Ford class. Of course, helicopters can come and go, and there is a helicopter attachment on board this ship when she's at sea with her air wing. The very long build and testing of this first vessel was approximately 13 billion US dollars. It was very expensive and very delayed because of all the new technologies involved and caused some criticisms. And I will leave those for the very end of the lecture, because for right now, we're going to celebrate what the United States has designed and built here, because it is incredible. Let's begin with these weapon systems that I talked about. Whenever we think missile systems, we often think of destroyers and cruisers and other ships. But this aircraft carrier has numerous ballistic and missile systems on board her. These are used for defensive purposes, by the way. This is not something that you would take into battle to shoot down aircraft or otherwise. But it's when adversaries attack this aircraft carrier, she has her own defensive layers. Let's begin at the bow. The Mark 38 remote control weapon system is a 25 millimeter chain gun, or I've heard it called a machine gun as well, that is designed to engage surface vehicles at about a 1 to 1.3 mile range. This is really for those unmanned surface vehicles that are being used right now in the Black Sea against the Russian Navy to come in and ram the side of the ships and explode. This type of weapon system would be ideal for engaging those drones before they hit the ship. But it could also be used for anything in the water, like a mine, a floating mine, for example, within 1.3 miles of the ship. This remotely controlled weapon system could easily engage and destroy things like that as well. If we move back from the bow a little bit, on the port side, we'll see the Mark 49 RAM. This is the rolling airframe missile system. It is a short-range point defense missile system, holds 21 missiles. It is infrared and inertially guided, and it's fire and forget. If a missile or low-flying aircraft comes within its engagement envelope, it will simply shoot it down. Directly across from it on the starboard side, we have the Mark 29 ESSM, accompanied by a Phalanx close-in weapon system. The Phalanx SeaWiz is a ballistic-based system shooting a 20 millimeter round, and the Mark 29 ESSM is a medium-range surface-to-air missile. It flies very fast. It can reach out to about 12 kilometers and destroy anything in the air inside that envelope. And that is the medium range portion of this defense. So we've seen ballistic defenses at short range. We have missile defenses at short range with the Mark 49 Ram. And we have missile defenses at medium range with the Mark 29. As we move amidships, on the port side only is a single, very lonely Phalanx close-in weapon systems. The SeaWiz sitting out there protecting the port side all by itself. Probably why you don't see one on the starboard side is that's where the aircraft elevators are. So it appears as if there's just not a place for it on the other side. But if we move all the way back aft to the very stern of the vessel, every single point defense and missile defense system is repeated back here. On the port side, we have the Mark 38 remote control weapon system accompanied by the Mark 29 ESSM. That's that medium range surface-to-air missiles. So we have medium-range surface-to-air missiles on both port and starboard side. This is equal coverage. This is very important. On the starboard side, we have the Phalanx CIWS. We have the Mark 38 25mm remote control weapon system for those drones. And we have a Mark 49 rolling airframe short-range missile defense system. So all those are represented on the aft end. And one reason why you have the majority, or about half, of all of your missile defense systems on the aft end of the ship is that in conflict, it is likely that the fleet will detect that an attack is in progress. They may not have all the details yet, but they will have a general direction initially before that gets narrowed down. The fleet will move away from the attack most likely. That way, it points half of the defensive systems on board this ship in the direction of the oncoming attack. That is just one reason of why you would see so many of these on the aft end of the ship versus, say, the bow or even the sides that are so much bigger. Sensors. Let's talk about sensors. We have a single graphic at the top of this tower saying that we have satellite communication. That is a understatement. This platform has every single communication that you can stick on a U.S. Navy vessel because of the role that it performs coordinating a battlefield at sea with forces ashore, in the air, and at sea. And then informing civilian leaders like the President, Secretary of Defense ashore, it has the communication antennas to do all of that. So just know that the top of this tower is full of both sensors and communication arrays. Now, below that, on the actual tower itself, we have a bit of a unique radar configuration here. This is for just Hull 1, so just the Gerald R forward, but not the whole class. We'll have a combination of the SPY-4 radar and the SPY-3 radar. These two radars will work together in a dual mode configuration. This is very similar to how the Zumwalt operates. And we'll talk about those in detail in the radar section. Just below that, we have a couple fire control radars, and that's used for directing weapons in flight. Here we have the names of the ships that are being built. Obviously, the Gerald R. Ford was commissioned in 2017 after a very long production, construction, and testing process. Iconically or ironically, she was commissioned while still performing sea trials. So we'll get into that at the end of the lecture. Now, the next haul is coming in 2025. So we'll very soon have two of these operating, which is incredible. And she'll be the John F. Kennedy. John F. Kennedy is going to be Hull 2. And John F. Kennedy is going to have a different radar configuration that we'll talk about in a second. And going forward, the next one, every 5 years, we're going to get one of these. The Enterprise will be commissioned in 2030. Doris Miller will be commissioned in 2035. Side note on Doris Miller, all of these ships are named after, iconic ships like the Enterprise or a president. Doris Miller is actually an enlisted man, and he is a hero, if you will, from the Pearl Harbor attack where he manned a gun and, helped defend an attack against the Japanese attack. And so he's getting an aircraft carrier named after him in his honor of his service. So that's a bit unique. They haven't named Hull 5 yet. They are going to build at least 6 of these, and 9 are planned, and we'll see how many they actually build. Because they perform 20% more air sorties than our current aircraft carriers, the Nimitz class. We don't need to build as many. We have 11 aircraft carriers right now. So if each aircraft carrier can do 20% more, we don't need to build as many. So they may only build 9. We'll have to wait and see, but just be aware that we're definitely building 6 of these, and we've named the first 4. Gerald R. Ford class by the numbers. So this is a nuclear-powered aircraft carrier pushing 2 shafts. She does use steam to generate electricity with steam-driven turbines and turn these 4 shafts. So this is still an old-school nuclear-powered steam-generating propulsion plant, as the Nimitz class is. Her crew is just over 4,500 souls when the aircraft's crew are on board, because that brings on a lot of people. Obviously, it's not just pilots, it's maintenance. There's so many more people than just pilots in the air wing, folks. The max speed of this ship is in excess of 30 knots. I was privileged to see some of the edited sea trial footage of her at sea doing high-speed maneuvers, and one that was a beautiful thing to watch, this massive 100,000-ton ship do high-speed turns. But she looked like she was doing a hell of a lot more than 30 knots, in my opinion. Publicly, 30 knots plus. She has unlimited range. That means endurance at sea. Much like submarines, she's only limited by food because she creates her own water for the crew, and she has nuclear power to produce electricity and drive the ship. So the limiting factor really is food, and because it's a surface vessel with its own air wing, it can shuttle food from ship to shore as needed. So it really is unlimited range. You know, until something breaks, this thing can operate for a long period of time. 25 or more aircraft can be in the air wing at once. And again, those are both unmanned tankers, which is that MQ25. That includes the helicopter wing, which is multi-role, but I would say primarily anti-submarine warfare, in my opinion. And then, of course, the fighter attack air wing as well. Her Mark 29 octuple ESSM launchers, she has 2 of those, 1 port, 1 starboard. She has 2 of the Mark 49 RAM point defense missile systems. Remember, that's the short-range version. The ESSM is a medium-range version. And she has 3 of the Mark 15 Bravo Phalanx close-in weapon systems, and 4 of the Mark 38 Mod 3 25mm remote control systems. On Hull 1 only, we have the Dualband Radar we talked about. That's Spy 3 and Spy 4. We're about to get into detail as to what those are. Just know that those 2 radars work together. You know, one is a S-band search radar, one is an X-band high-frequency, high-fidelity radar, and they work in dual mode, working together. Now that we have the Spy 6 radar, and that's being installed on Hull 2 and all the hulls going forward, Spy 6 and SPQ9 radars will be working together on those future hulls. Now, Raytheon SPQ9B air search radar is installed on these. They also operate the SPS-73 surface search and navigation radar. That's a very high resolution surface search radar that can be used for navigation, obviously. They have 4 of those Mark 9 fire control radars that I showed you on the tower. Those are for weapon direction and control. The SLQ-32 Bravo SWEP Block 2 electronic support measure system is a mouthful, but it's very important. This is the system that is used to detect and classify any kind of radar transmission that's out there, or communication, radio, anything that has electromagnetic signature. This thing will detect, classify, tell you all sorts of things about it, like what mode it's operating in, things like that. It's very powerful. The SRQ-6 SSEE mod of the electronic countermeasure system is secret. We will not be talking about it. It is installed. The SLQ-25 Nixie underwater decoy is probably the only thing about this ship that I think is vulnerable as far as defenses go. The Nixie, although it has been upgraded and modified throughout its life, is an old system. It IOC'd, I think, in the 1980s, maybe even a little bit before that, for testing. Every modern torpedo in every country knows what the Nixie is, what it sounds like, and how to avoid it. So that's a problem, in my opinion. But I imagine the modern Nixie that is on board modern ships probably has a new mode that I don't know about, and I'm going to give the Navy the benefit of the doubt because everything else about this ship is extreme survivability. You can throw everything in the kitchen sink at this aircraft carrier and it will defend itself. You know, you're going to have a hard time sinking this thing. You're going to have a hard time getting a weapon on target with this thing. Links. Links are communication links between ships, between platforms in space and ashore. So that's link 4, link 11, 16, 22. This is for target sharing, weapon control, you name it. It's literally a wireless network of communication that shares system information between radar, weapons, and their detections. So, for example, you can shoot a weapon from a ship, an Arleigh Burke, for example, and as that weapon is in flight, the communication from this aircraft carrier can update the target to the weapon, much less the ship itself, just as one example. It does things like that. It's very capable. Okay, so air power composition, like I talked about, is in excess of 25 airframes, whether they're helicopters or the F-18 Super Hornet or the F-35C. You can mix and match those as much as you want. Just know that they're going to have a lot. If we were to compare this to the Chinese aircraft carrier, its new one has a maximum, and this is just theoretical, they haven't even done this yet, but they can put 40 aircraft on that ship. So it's literally half of one of our aircraft carriers right now. And like I said, we're going to build multiple of these. Okay, let's talk about what we can about the A1B nuclear reactor. This is a new design, a new reactor for this class of ship. It is a steam-based nuclear reactor, so it's going to have all the bells and whistles and noise-making components and condensating, feeds of a normal nuclear reactor. But it produces 700 megawatts. This thing is huge in terms of power output. It's 25% more than what the Nimitz has. And keep in mind, the Nimitz has multiple reactors, and so does this ship. So it's still 25% more. This provides electrical power to everything. Hotel loads, the EMALS catapult system, electricity is not a problem. And this is by design, folks, because direct energy weapons are coming to the U.S. Navy. That's a sensitive program that's been in development for decades now. It's been forever because the direct energy weapons are very difficult to get right. But they are coming, and in order to use them, we need to produce enormous amounts of electrical power on board our new ships. So the Arleigh Burke Block 3, the Gerald R. Ford aircraft carrier, even the Constellation class frigate has electrical power in excess to eventually power these high demand direct energy weapons. Lasers are coming to this aircraft carrier. Also, it reduces the amount of maintenance you have to do by having things be more and more electrically driven versus mechanically gear driven. That reduces the amount of wear and tear, upkeep, and manpower on board to maintain these systems, which is how you can have such an enormous ship with only 4,500 people on board. Whereas if we didn't have these types of systems that were more electrical than mechanical, we would have well over 5,000 souls on board. And that greatly increases the demand on both personnel and keeping people at sea for longer periods of time, more people. So this electrical generation, this method of powering ships and systems through electricity versus mechanical is a great direction that the United States Navy is going. And then finally, of course, the EMALS Electromagnetic Aircraft Catapult is state-of-the-art. We were the first to do it. The Chinese did copy us because they do have one as well now. But because we produce so much electricity, we can fire off our ships or our aircraft over and over again without having to generate steam. That's what makes that so great. Okay, EMALS Catapult. Kind of already talked about it. It's manufactured by General Dynamics. It is simply a low-maintenance, highly powerful, electrically driven sled that you can put the front gear that is reinforced of aircraft on top of the sled or in front of it, and it will literally push anything attached to that sled off the bow of the ship. Now, when this is an airplane, that's a great thing. So this is how we push our airplanes up into the air. Everything from, our supply planes that come down, little tiny cargo planes, to the F-18 fighter that you see here in the picture, gets pushed off the bow electrically now. And again, less maintenance, requires less people, and is more reliable. It's all around a great system. Dualband radar. This is only on Hull 1. It's also on the Zumwalt class, but we're not talking about that. The Gerald R. Ford Hull 1 is going to have both the X-band SPY-3 multifunction radar, which is that high update rate, puts weapons on target. You know, it's a multifunction, it does more than just weapons, but it's a very high fidelity radar. That's combined with the SPY-4 S-band radar. The SPY-4 is a volume surveillance radar. It illuminates entire swaths of the airspace around the fleet all at once. So imagine, you know, older systems, if you were to go back to, say, even World War II, you're watching a radar go around and it has a single line and it's just spinning like the dial of a clock. Well, this is much more than that. We're projecting pie slices out into airspace and illuminating large portions of the air all at once. And that's directional too. We can move it around, of course, or just leave it static, and anything in that pie slice volume of airspace is continuously detected. Anyway, these two work together. So they'll have 3 fixed radar panels working together, and it was only used again in Hull 1 because SPY-6 has come along, which has even better capability without having to use 2 different radar systems like this. Also, these capabilities support SM-2 and ESSM. SM-2 is a surface-to-air missile. So again, you could be directing missiles with these radars if you wanted to. Missiles that are not shot from this ship, by the way. Missiles that are shot from neighboring ships that are maybe in the fleet. Okay, SPY-6 radar. This thing is really advanced. It's made by Raytheon. It is an air and missile defense radar all at once. This thing spins around. And it's a 3D active electronically scanned array. Operates in the S-band, which is 2 to 4 gigahertz. And it has a solid state Ganymede transmitter. Very high quality, basically. And it that allows it to use high power, like 1,500 kilowatts transmission. This is also used on the San Antonio LPDs. Those are ships that carry Marines and support marine-to-shore operations. So the San Antonio class, just as a sidebar here, was the first American ship to have the integrated power system, and is also a test platform because of that power system for direct energy weapons. So the San Antonio class also has this radar, so they generate enormous amounts of electricity, even though the San Antonio is conventionally powered. I should mention that. But just know that this radar is on all sorts of different ships, including the new Arleigh Burke Mark III, Block 3. This is our latest and greatest radar. The SPQ9 radar is the fire control radar that's paired with SPY-6. So whenever you see SPY-6, think SPQ9 as well. And this is a pulse Doppler, frequency agile, detects and tracks low radar cross-section targets. And that's really key because stealth, if I can for a second divert onto that topic, stealth has 2 major categories. You have the ability to detect something via radar that's stealthy, and then the ability to put a weapon on that with your X-band radar is completely different. For example, the F-35 Charlie, the airplane that is operated off this class of ship, is a stealth airplane, but you can detect it with a simple S-band search radar. So how can you possibly claim that this is a stealth aircraft if you can detect it with a simple search radar? Well, its stealth characteristics are designed specifically to defeat X-band and other weapon band radars. So yeah, you can see the F-35, but when you go to launch a missile at it, the missile can't see it. And that's what matters. So, but SPQ9 Bravo, designed to see those low radar cross-section targets and put a weapon on it. All right, peak power 1.2 kilowatts. Range may surprise you, 10 nautical miles. Very short range. Keep in mind, we're not taking the carriers directly into battle. So this is going to be, you know, practically point defense range at this point. SLQ-32 Bravo version 6 is the Swept Block 2. This is the ESM and ECM working together. Electronic Support Measures is what ESM stands for. This is the most advanced electronic countermeasure system in the Navy. The Block 3, which is recently released, is on the Aegis Block 3. But these are very capable and can defeat and, I'm told, literally melt radar arrays if they get too close. These things are designed to jam radars, provide false targets, which they won't tell me how it does that, but apparently it can take this aircraft carrier and make it appear somewhere else on someone else's radar screen, which is crazy. And it could also do multiple ships. It could make this ship look like two. And so whenever a weapon's trying to attack a carrier, when it has 6 choices, which one does it choose is kind of the idea behind that. And it does much more than that as well. And this is only the Block 2. Like I said, the Block 3 is on the Arleigh Burke. These are very advanced systems. How they do what they do is a closely guarded secret. Just know that it's the best and it's installed. Electronic warfare system. Okay, Mark 38 Mod 3 remote control weapon system. This is made by BAE. This is an unstabilized machine gun, and it's designed to engage surface ships. Like I said, those unmanned surface drones or small vessels that are close by. If they get within 1.3 miles, this gun can engage and destroy it. It's a 25 millimeter round. It's high explosive. It shoots 180 rounds per minute. Now, the most important thing in this description is that it is unstabilized, which means every roll the ship makes at sea is going to throw off your fire control solution. So there's always, in automatic mode, it's being corrected, but it's not self-stabilized in the component itself. It has to adjust its aim for every little movement the ship makes, causing it to be little less accurate than it would be if it was on a stable, say, land platform shooting a static target. So that's something to consider whenever we're talking about naval guns. Most naval guns are stabilized. This one is not. Here's a Mark 49 rolling airframe PDMS. This is a self-protection defensive system, short-range surface-to-air missile. It has 21 missiles in its magazine. These can be reloaded. I've seen photos of them reloading this by hand. So there's no automatic reloader. You got to get sailors up there with a missile and shove it in the tube, I guess. This has a range of 12 kilometers, and it is INS and radar and infrared guided. It's fire and forget. Once you launch this thing, it doesn't need those fire control radars. It guides itself, but it gets up to speed so quickly, and the range is so short, its time in the air, its flight time is just a matter of seconds. It's very, very quick. Here's the Mark 29 ESSM, and this is that medium range surface-to-air missile defense. There's one of these port, one of these starboard side, and each has 8 missiles and is just designed for air defense. This is a semi-active radar homing. That's Block 1, and then it has dual mode for Block 2. Max speed is Mach 3, and the range is in excess of 40 kilometers. So this ship does have the ability to reach out and destroy aircraft at those ranges, including incoming cruise missiles. Mark 15 Phalanx CIWS, very common on board every single Navy warship in the fleet. Shoots a discarding sabot round, APDS. Shoots multiple rates of fire. Just know they're all measured in the thousands of rounds per minute. So this thing can put a lot of lead downrange very quickly. Its effective range is about the same as that remote control weapon system, but this one is fully automated and well, kind of stabilized in that it has its own onboard radar system to kind of keep it on target. But you can take manual control of this and shoot it from inside the ship with a little joystick, just like you do the RW or the remote control weapon system. All right, let's talk about the air wing now. We're shifting from propulsion and point defense now to the offensive capability. The whole reason why we have an aircraft carrier is to put these planes on it. And the most common plane is the FA-18 E and F. That's the Super Hornet. E is single-seater, F is dual-seater. There's also a Growler that we'll talk about, which is a dual-seater as well. So Block 2 is in service now. Block 3 is being delivered. Matter of fact, at the time of this recording, Boeing, who makes this plane, just delivered a whole new batch of Block 3s to the U.S. Navy. So we are definitely employing Block 3s right now as you're listening to this, which is the latest version of the FA-18. It's a twin engine. It has capability of doing 1.6 Mach, so it is a supersonic fighter attack aircraft. The APG-79 is an active electronic scanned array radar. It also has IRST, which is infrared track capability, and it can shoot the new AIM-260, which is the Joint Attack Tactical Missile, or Joint Air Tactical Missile. It's a very long-range missile designed to complement the AIM-120 AMRAAM and eventually replace that. And the thing that's joint about that is, of course, the Air Force will be using it, and we'll be sharing it with our NATO allies as well. And so whenever everybody's using the same weapons, it makes that supply chain a little more efficient. And so that's the idea behind that. So the AMRAAM is being eventually going to be replaced, and it's going to be the AIM-260 JTAM that eventually does it. If you're watching the graphics here, you can see all the different weapon configurations on the right-hand side. I won't read those out, but just take a moment to look and appreciate how many different weapons the FA-18 can hold. Now, if you thought that was a lot, take a look at this. The F-35 Charlie Lightning is quite the platform. This is a 5th-generation fighter built by Lockheed Martin. It does have a single turbofan afterburning engine on board, which for naval aircraft is a bit of an exception. The U.S. Navy up to this point has consistently demanded from aircraft manufacturers that they have 2 engines on every aircraft, because if you have one fail and you're over water, you're not going to land, you're going to crash. So having that second engine in an emergency has been key. But for whatever reason, they've went with the single F-135 afterburning turbofan engine. Now, this single engine is powerful, and the fighter is light, so it can get up to Mach 1.6, which is the same as the F-18 in terms of speed. But it does have a lot of stealth characteristics. Remember, I told you about how targeting stealth or low radar cross-section aircraft work. You're going to have a hard time putting a radar-guided weapon on this aircraft. You're going to have to rely on other means like infrared or object shape detection, something else. She does have the APG-83 active electronic scanned array radar, which is an upgraded one, and electro-optical targeting system, which is a passive system. It can be active, I suppose, but you can passively track the shape of a target with this system. And when that happens, the target has no way of knowing it's being tracked passively. Also, it has a directional awareness system. That's really secret and sensitive. Not going to talk about it. Just know that this platform has a lot of capabilities, including it can play the role of, say, a quarterback, if you will, on a frontliner team of FA-18s and coordinate an air attack operation in flight in real time if it needed to. That would be a great role for this. So it does many things more than just carry weapons to the battlefield. It brings a lot of situational awareness and coordination, not just to the theater, but into the battle itself. And that's a great capability. All right, here are the weapons you can put on this thing, and it's a lot. So I'm not going to read these out. If you're watching this, take a moment to pause the video and just look at all these. But it's everything from external gas tanks to the Shadow Storm missiles and all the smart weapons you can think of, to internally stored dumb and smart weapons, air-to-ground weapons. Just about every single air-to-ground weapon in the NATO inventory can be dropped from this thing, including air-to-air weapons, of course, like the Air Intercept Missile 132 and the AIM-120 AMRAAM. And then a number of guided weapons as well, both internal and external weapon pods here. It pretty much does the majority of NATO's air weapon inventory. Here's the EA-18G Growler. This is a very unique plane that is not talked about much because it is extremely sensitive. It is built on the FA-18F twin-seater Super Hornet airframe, but it has a completely different mission. It is an electronic warfare airplane. It brings into the air a number of pods, and this is called an ALQ-99 electronic warfare system. And what it does is it gets up with the air wing, and it can look out for, long ranges at what kind of electronic environment are they in terms of air search radars that the opponent is using, where those radars are and what modes are they in. And then, because it has a backseater who's analyzing all this information, can specifically target and blind those radars, including missiles that are in flight. A lot of long-range cruise missiles are controlled and updated mid-flight by other means. Well, this can interrupt that communication, that link, if you will, between a cruise missile in flight and its update source, whether it's space-based or land-based or sea-based. It can interrupt that communication. Just as one example, it does much more than that, and it's all highly sensitive. Just know that it does carry the HARM missile, which is a anti-radiation missile that can go out long range. The extended range HARM is very long range and destroy a sea-based or land-based radar. It also has the ability to shoot the AIM-120 and AIM-9 Sidewinder missiles for air defense. That would not be its primary mission, but if it needed to defend itself against another airplane, it could. But its primary mission is electronic support and attack. This is an offensive, capable electronic warfare platform that is not talked about. All right, one that most people recognize because of its unique shape is the E2 Delta Advanced Hawkeye. This is an airborne early warning and control radar system. It has a whole crew on board, basically an air traffic controller in the sky that does both air search and surface search across hundreds of miles. And they coordinate all sorts of in-air activity. They're essentially the eye in the sky for everybody, not just the air wing, but the fleet itself, updating everybody on what's going on. It can stay in the air for up to 6 hours, and it can refuel, so it can stay in the air even longer than that. Because it's up thousands of feet in the air and it has a 360-degree radar, it has full vision in all directions of everything happening all at once. And something that you need to remember is it's more than just air search. This can track surface contacts as well. The radar name is the AN-APY-9, Active Electronic Scanned Array Radar. Very long range. This particular version IOC'd in 2014, but we've had the Hawkeyes, these E2s, for decades. Here's the MH60R Sea Hawk. This is, as far as helicopters go, the workhorse of the naval fleet for helicopters. The primary mission, in my opinion, is anti-submarine warfare, but these long endurance, 3.5 hours endurance, very durable, very reliable sea-based helicopters are multifunctional. They can do surface search. They can provide ESSM capabilities and updates. They have their own onboard ESSM system. They also have the forward-looking infrared and other passive optical systems for tracking and targeting and sharing information. But since they've gotten rid of the Vikings, which were the S-3 anti-submarine warfare fixed-wing planes from the U.S. Navy a few years ago, this platform, the Sea Hawk, has really picked up the mantle in getting over a submerged detection quickly, getting a sensor, whether it's a dipping sonar or a sonar buoy, on a presumed submarine, and a weapon on that submarine if need be, rather quickly. So even though we've lost the ability to use the S-3 Viking to do that mission, which was faster than a helicopter, this helicopter has really picked up the pace in terms of ASW warfare and capability. Honestly, in day-to-day peacetime operations, this helicopter is really used to resupply the fleet a lot. You'll see the air wing helicopter constantly doing vertical replenishment from supply ships and even the aircraft carrier in some case to other vessels inside the fleet. So she is, by definition and with pride, a workhorse of the fleet, keeping all the ships well supplied, as well as performing critical missions like ASW warfare. Here's the MQ25 Stingray. This is an unmanned aerial vehicle used for refueling aircraft. It's been in development forever. I've seen reports where it is operational, and I've seen reports where it's not. So I'm not 100% sure what the status of this thing is, other than it should be operational by the time you hear this. And this is used, again, just to refuel the airplanes that are coming off the aircraft carrier. Before this system came online, that job was performed by an FA-18 with large external gas bags on board, and a little drone like you see here, a little hose that other airplanes would come up and refuel with. And what that did was that took one or more of your F-18s out of your air wing and kept them from doing missions, because they had to do this refueling mission to support everybody else who was flying missions. Well, the MQ25 Stingray is doing that refueling mission now, and it can autonomously do this mission, take off, do the mission, and then return to the carrier, land safely, catch that 3-wire, and do it all with AI. No human intervention at all, other than some simple communication commands if it needs it. But it's completely autonomous. Very cool technology. All right, final thoughts on the Gerald R. Ford class is this is really an incredible ship. It really is. It's not just about how big it is, even though that's quite a feat. We've built something here in the United States that no other country has done yet. This over 100,000 ton, behemoth of a ship. But with that size brings more capability in terms of air wing and offensive air power. In this case, 20% more to each aircraft carrier. And we're getting our second one in 2025, folks. And we're going to get a new one, an additional one every 5 years after that. This is really great. The electronic email system for catapulting airplanes off the ship is great because that is lower maintenance, it's more reliable, and it can launch more aircraft without having to generate excess steam from the power plant on board. It just uses electricity, which greatly simplifies its operation and its maintenance and its manpower. So some of the downsides, this is the most expensive ship ever built, ever for a single ship. It was behind. It had lots of problems. It took about nearly a decade to get the thing working properly. It has a lot of new technologies on board, one of which was the EMALS program, but there's other smaller technologies that we didn't really go into that had to be tested, and that's what caused all the delays and cost overruns. But we're dropping $12 to $13 billion on each one of these now, but we are producing them, or delivering them, I should say, on 5-year intervals versus the 10-year, nearly decade it took to get the first one out. The UAVs are going to add to the capability by taking that F-18 away from the refueling program, allowing more or every single fighter attack aircraft on board to perform that fighter attack mission versus conducting refuel missions for the rest of the air wing that I'm sure no pilot wants to do. They want to go out and do their fighter role. They don't want to be a tanker. So the UAVs are a huge part of that. And this additional electrical generation is key. Do not forget about this. We will be installing direct energy weapons on our ships. The LPDs already have them, although those are one-offs and test systems. The Constellation, the Gerald R. Ford, and maybe the Arleigh Burke, if they have space for it, will eventually get direct energy weapons. And it's because they have this additional electrical capacity to power those. This is an incredible ship. It's incredibly expensive. It took an incredible long time to build. But now that we have these and we're producing them every 5 years, it's going to ensure that the United States Navy stays the most powerful Navy in the world in our lifetime. Thanks for listening, everybody.